In this problem, we're asked to sketch the magnitude characteristic of the Bode plot, labeling all critical slopes and points for the function shown there. First thing we want to do is we want to convert to standard form. Okay, so our first step, convert to standard form. Okay, and to do that, for instance, we'll have 10 to the 4th, and to convert this first term to standard form, we're going to divide through by 2, so we'll have 2 times 1 plus j omega over 2. And down here, for this term, we'll factor out a 10. We'll have 10 times 1 plus j omega over 10. And then we'll have 100 times 1 plus j omega over 100. So if we go through and look, we have 10 to the 4th, 10 to the 3rd, so this becomes 20 times 1 plus j omega over 2 over 1 plus j omega over 10, 1 plus j omega over 100. Okay, so now we're in standard form, and if you notice, just kind of look at the terms here. Here's a constant. We have a simple 0. Okay, so let's just kind of take a little inventory here. First we have a constant. We have a simple 0. And you notice that simple 0 is at omega equal 2 is where kind of the break point is. We have two simple poles. One characterized by 10 radians, one characterized by 100. So now, let's go through and look at those terms. So for our constant term, here's the Bode plot for it, magnitude sketch. So we have 20 log base 10 of 20, so that's 20 dB. Okay, so that gives us for the constant term. Now for our simple 0 at omega equal 2, here's the sketch for it. Has a gain of 0 until we get out to 2 radians per second. Then it turns up at 20 dB per decade. So that tells us about that simple 0. And now we have the two poles. So the simple pole at omega equal 10, you notice it has a gain of 0 until we get out to 10, and then it rolls off at minus 20 dB per decade. And then our last term is a simple pole at omega equal 100. And there's the plot for it. Notice it has a gain of 0 out until we get to omega equal to 100. Then it breaks down at minus 20 dB per decade. So now, let's sketch the plot for all of those for that function. So we're going to start off, we're going to sketch our plot. We'll start off at 26 dB. That's where our constant is. And we stay at that until we get to omega equal 2. That point, our plot, we break up at 20 dB per decade. Okay, so that's where the simple 0 turns on. Then when we get to omega equal 10, we have one of the simple poles. It turns on. Okay, so at omega equal 10. So now, remember this 0 has a slope of minus 20 dB per decade, so those two slopes cancel out. We stay at this level until we get to 100. Then the second simple pole turns on. And now we break down at minus 20 dB per decade.